Optics. You have any doubts in this one or any specific doubts?
No, sir.
Yeah. So light is a form of energy, and
Mm.
part of light
Mm.
is called ray, and ray is
Okay, sir.
collection of beam is collection of rays.
Mm.
Like this one is one single ray. This thing
Mm.
you can call it as a beam, parallel beam of rays.
Mm.
And the source of light ray is the one from which the light is coming out.
Okay, sir.
And there are certain objects which we give out, like they are called luminous objects. For example, sun is a
Mm.
luminous object, but moon
Okay.
is not a moon. What we see as white thing is the uh,
Mm.
sunlight which is getting reflected from there.
Okay, sir.
So moon is not a moon also giving out light, but it's not its light. It's a reflected light from the sun.
Sun. Mm.
Properties of its form of energy, travels in straight
Mm.
line from medium to propagate. This also an important thing to note because between sun and the earth, surrounding
Mm.
the earth, there is earth's atmosphere. But after that, there is some
Okay.
almost nothing, vacuum. But still, the light from the sun is going through that empty space and then entering the earth's
Mm.
atmosphere. Okay.
Okay,
Otherwise,
sir.
the sunlight will not come to the earth if this is not possible. Without any medium,
Okay.
the light can travel.
Okay, sir.
Only because that we are able to receive the sunlight.
Mm.
The speed of light is 3 into 10 to 8 meter per second if it is vacuum or air.
Mm. Mm.
Otherwise, the speed will go down if the medium is dense.
Okay,
And
sir.
the relation between the speed and the frequency and
Mm.
the wavelength. See, this wave will have two things. One is a time variation and the space variation.
Mm.
Light is like a wave.
Mm.
Okay, it's varying like this. Okay, suppose this is the variation with respect to the space, say x, and there
Mm.
is a time, initial say time t naught.
Mm.
So at a
Mm.
later time, it will move like this.
Okay, sir.
So this is a later time t1.
T1.
Or if I fix a point in space,
Mm.
so at this initial time,
Mm.
t naught is here,
Mm.
it has gone here. So for a given point in space, I can plot this as a function of time. Then also it will be a variation like this. Understood? No. This is like a
Ah.
as time progresses with space, the thing is,
Mm.
but for a given point in space, I'll see how the value is changing.
Mm.
Assume this is like a wire like this
Mm.
moving.
Mm.
Okay,
Mm.
so at this point, at this
Mm.
time, the wire is this much value, the height.
Mm.
Later time in this
Ah.
wire value is this much. Okay,
Okay, sir.
after this one. So that if I plot as a function of time, it will look like this.
Mm.
Okay, so this time variation will have a periodicity. Periodicity is after how much
Mm.
thing it's repeating. So this one time period.
Mm.
So this periodicity
Okay,
is
sir.
called capital T, and the reciprocal of
Mm.
capital T is the frequency.
Mm. Mm.
T is in seconds. So nu is in 1 by
Mm.
second, and 1 by second is same as hertz.
Mm. Okay, sir.
And this space variation does also have a periodicity, and this periodicity
Mm.
lambda.
Okay, sir.
It will be in say meters, SI units. Okay,
Mm.
so they will have basically two things. One is variation with respect to time, and with respect to
Mm.
the simple thing is both will be sine. Okay,
Okay, sir.
that is possible if there is a sine. Assume there is a wire which is bent like this in form of sine.
Mm.
This particular time, there is a variation in space.
Mm.
But as I'm moving
Mm.
this wire towards right, so given point in space, I'll see at what point it is
Mm.
in the uh, this
Mm.
location. That if I plot with respect to time, the variation
Mm.
is.
Mm.
So we will basically have space variation and time variation,
Mm.
plus periodicity.
Okay, sir.
Periodicity means after how much time it's repeating. I can also take
Oh,
time between this and this as period.
okay.
Repeating, right? See,
Ah.
day I can say from 4 a.m. to next day 4
mm,
a.m. as one day.
mm,
Okay, or 3:59 a.m. Okay. Similarly, I can also say 5 a.m. to 5 a.m. as one day.
mm.
I think I'm right. 24 hours duration.
Yeah.
I can also say from 10 a.m. to the next day 10 a.m. Similarly, here also
Mm,
I can different between these two.
mm,
After the same thing is repeating, or I can different between these 2 points.
mm.
Same thing is repeating. Or I can say take also to this point, and
Okay, sir.
after that it's repeating. Okay.
Mm,
Points are this one 0 to 0, or maximum to maximum,
mm,
or minimum to minimum.
mm.
Similar space.
Okay.
Okay. So
Mm,
these two periodicity, space periodicity is
mm.
lambda, and time periodicity is 1 by nu.
1 by new. Okay.
Plus the relation between the time periodicity t and nu is reciprocal.
Mm. Okay, sir.
1 by t is nu. Okay.
New.
So
Okay.
this in
Ah.
seconds. So 1 by second, we call another unit called hertz.
Oh. Okay, sir. Yeah.
So this wavelength, yeah.
Mm,
So blue color will have particular wavelength and
mm,
particular frequency, and
mm.
red will have different wavelength and different frequency. C is same.
Oh, okay, sir.
Different colored light have different wavelength and
Different.
frequency. Okay.
Mm,
So if you take white light, C is same for all colors, but nu is
mm,
different colors. Similarly, once this is changing, lambda has to change so that the product is constant.
mm,
Because if nu increases a little bit, lambda has to decrease
mm,
a little bit so that the multiplication is constant.
mm.
Visibly, it has the lowest wavelength and red has the highest wavelength. You remember one thing, red
Ah.
for red,
Mm,
the opposite is other for other one. So lambda red is maximum, lambda violet is minimum, and
mm,
the sequence is Vibgyor.
mm,
This right, Vibgyor, violet, indigo, blue, green, yellow, orange.
mm,
After that, it's invisible.
mm.
Okay, so in this has got the maximum wavelength.
Okay, sir.
Frequency is the opposite. New will have new
Mm,
frequency, new red will be
mm.
less. Okay, and new for blue or violet will be more.
Okay.
Violet and red.
Mm,
Two media means one is say air.
mm,
If you say two media, one wireless instrument interface between two media, okay,
mm,
then other one can be water or glass,
mm,
some different media.
mm.
If the light is going like
Okay.
this, if there is no change in medium, it will go straight like this. Okay, but
Mm,
since it's a denser medium, I will draw it properly.
mm. Oh,
If there is
okay.
no change in medium, it will go continue the same direction
Mm,
like this. Okay, you draw it with scale, and at this point, I can draw a normal to the
okay, sir.
interface. So instead of going straight, it will come here towards the normal. Okay, that will see it.
Mm,
So basically, there will be change in direction when there is a change of
mm,
medium.
mm,
That change in direction is called refraction. Deviation of ray is
mm.
called refraction.
Okay, sir.
Difference in velocity. And since the water is denser compared to air, okay, so
Mm,
velocity in
mm,
C in water is less compared to
mm,
air. This C 3 into 10 raised to 8, that value is valid
mm,
for air or
mm,
vacuum. So water is denser
mm,
than this. When it's denser means the velocity will go down.
mm, mm.
Velocity in water is less compared to air.
Okay, sir.
So velocity
Okay, sir.
more in rarer medium, less in denser medium. Okay.
Mm, mm.
So if it goes
Okay,
to
sir.
refraction is the bending of light when it goes from one medium to another medium. This is basically refraction. Air to water or air to glass is
Mm,
the medium. So at this point, there will be a deflection. That is refraction.
Okay, sir.
First law, incident ray, refracted ray, and normal with the diagram.
Mm.
Move diagram. Show me diagram. This is the say interface. Here we have
Mm.
air and say glass. Glass is denser compared to air. So the light ray which is coming like
Mm.
this will hit here.
Mm.
What is this ray called?
Incident ray.
Incident ray. And this is normal. Normal means we have to a line you can draw
Mm.
perpendicular. No. Similar to the surface
Mm.
of you can draw perpendicular. For the table, you put the pencils
Mm.
vertically up. That's the perpendicular.
Mm.
Okay. So this is actually a surface. So to a surface, I can draw a vertical line. Okay. So if
Mm.
there is no change of medium, it should go straight like this without any deviation.
Mm.
I have to draw it properly. Okay. But instead, since the density medium will go towards the normal.
Okay, sir.
This is the normal. So this is this. What is this angle?
Mm. This angle is
Angle of incident.
mm,
The
angle of
incident ray,
incident.
the
Oh.
angle between the incident ray and the
Mm.
normal. Normal is a reference.
Okay.
And this
Okay,
ray
sir.
is refracted ray
Mm.
or angle of refraction. Okay, so
Mm.
R will be less than I if this thing is
Okay.
denser medium.
Mm.
Whichever is denser medium, that angle will be less.
Okay, sir.
So this, see, any two lines will form a plane.
Mm.
If you have two lines, so this is the plane formed by the two lines. Okay, so one line can be like this, other line can be out of the this plane of this thing. Then also I can join these two by a I can form a plane which has
Mm.
two lines. But suppose I have a third
Okay, sir.
line, I have to draw this third line in this here itself. If you draw it slightly outside, then it will be two different planes.
Mm.
This plane could be different from
Mm.
this plane. But
Okay, sir.
if it has to be same, then I have to push it to the same plane.
Mm.
Like if you take 2 points, there'll be always in a line.
Mm.
Okay. Even if you move the second point to here, say, if I do this,
Mm.
you can draw this line like this. So 2 points will always be in a line. But suppose I take a third point and say it has to be in the same line, then I have to place it properly here only. Only then all the three will be in the same line. Got it? No. 2 points will be
Ah.
there. They are in the line because I
Ah.
draw the line like that.
Okay.
But if you say 3 points are in a line, like this, it won't be in a line. I have to place a third
Mm.
point here only.
Mm-hmm.
Only then I can form a line like this.
Okay.
Similarly, any two
Okay.
lines, anywhere I place, they will be in one plane only. Like 2 points
Mm.
always in a line. But if you want to make the third line to be in the same line, I have to place it properly.
Mm.
Okay. So here,
Okay,
I have
sir.
one line incident ray, second line refracted ray. Okay. Third line is this normal. Normal is also line, no perpendicular
Mm.
to the surface.
Mm.
Okay, this normal and incident ray is like this.
Okay.
Refracted ray is like this. So all these three
Mm.
lines are in the same plane.
Mm.
Okay. So that is first law.
Okay,
Incident
sir.
ray, refracted ray. Ray is same as light, sorry, line with the arrow mark. And normal.
Mm.
Basically three lines. Okay. Same plane. That is
Mm.
first law. That's always true. And second law is this
Mm.
suppose I can if we increase this angle of I, then the light is coming like this. Okay. So in this case, second case is I2. So I2 is greater than I1, right?
Mm.
We call this first one as I1.
Yeah.
So
Mm.
then this second light will come like this, say.
Mm.
with the angle R2. So R2 is
mm,
greater than R1. So the result is if I
okay,
increases, the angle of refraction also
mm,
increases.
okay, sir.
Okay, when this is true, sine
Mm,
I, when I increase, sine I will
uh,
increase. Sine R also will
uh,
increase. So another result is
okay, sir.
sine I increases, sine R will increase also.
Mm,
Okay,
okay,
so and this, so both are increasing. That thing can be expressed
mm,
as,
uh,
right.
okay, sir.
So that means
Uh,
another way is saying when
mm,
see when x increases, y also increases.
uh,
Means y is proportional to x, right?
okay,
That means sine I is proportional to sine r. Okay, so this means the ratio y by x is constant.
mm,
That is the meaning, right? Proportional. So similarly here,
mm,
sine I by sine r is constant. That is called refractive index of second medium with respect
uh,
to medium.
mm, mm,
Here, sine I by sine r. So mu2 by mu1 is, this is second medium where the
mm,
refracted ray is there. So this,
okay, sir.
another short way of rotating writing is 2 with respect to 1, which mu2 by mu1. So refracting is second medium with respect to first medium. So sine I by sine r
Mm,
is,
mm,
uh, okay. So light going from air to
mm,
glass, air to glass. So
mm,
the refractness of glass is greater than 1. So
mm,
sine I,
mm,
this is greater than 1.
okay,
Refractance of glass with respect to air. So that means that sin A is greater than sin R. That means I is greater than R.
mm,
So in the denser
uh,
medium, the angle is less. It's
uh,
going close towards the normal.
okay, sir.
This is the rarer medium air. Okay, something of this, when it enters the denser medium, it goes towards the normal. So that way R is less than I.
Mm, mm,
And also the speed in denser medium is less, right? Speed in glass, speed of light. Speed of light in glass is less than speed of light in air or vacuum. Okay, this is 3 Newton string. This is less than that. And this ratio
mm,
is less than 1 or greater than 1.
mm, less than one.
Less than 1. So it's 1 by mu.
Mm,
Because mu is greater than 1. For glass, it's around
mm,
1.5. Okay,
mm,
approximately. So it's 1 by this one. So another second, right?
uh,
Refractive index as um,
yes, sir.
velocity in air, that's C, divided by the velocity in the medium, it's V.
Mm,
Okay, so it's basically ratio of velocities. The way to remember is this one, if it is glass with respect to air, then it's greater
mm,
than 1. So that means more should be on the top.
mm,
HC should be at the top.
okay, sir.
That's basically the thing. Speed is low if refractive index is high. That means denser medium.
Mm,
And this example of air and glass. Okay,
clear and clear.
speed of light in glass is less because it's denser,
Mm,
and the factor is 1 by mu
mm,
if it is glass by air. Okay, or refractiveness I can represent as C by mu, and this refractiveness should
mm,
be greater than 1. So that means velocity in air should be in the top, velocity in glass should be the denominator. So here is the opposite, traveling from denser
mm,
to rarer.
mm,
That is from
mm,
glass to air. So it's going like this then.
okay, sir.
So instead of going straight, it will go away from the
Mm,
north. So this is
mm,
If you can call it R, this is I. So
Mm.
the R is greater than I
Huh?
because this is my first medium.
Okay, sir.
Okay. So it's going in the reverse direction.
Mm.
When light travels from rarer medium to denser medium, just
Mm.
have this example. Air means air. Example. Denser is glass. Okay.
Mm.
Refracted ray is bending.
Mm.
When air travels from the rarer medium. Sorry. This is the first case, normal case,
Mm.
forward case. So it's towards normal.
Mm. Mm.
It'll go like this. This is normal. In denser, it should go closer to the normal because that is the
Mm.
shortest path. So instead of composite light, another thing is this refractive index, mu, it's dependent on the color or the wavelength.
Mm.
What is difference between
So.
uh, refractive index of glass,
Mm.
refractive index of glass with respect to air? Suppose it's saying 1.5. Okay, you
Mm.
should ask for what light because this one for red it will be slightly different
Mm.
from code and the same
Mm.
material is in air and glass, but for blue it will be different. I'm not sure which one is bigger. So
Mm.
one is 1.37, one is another one 1.4. Okay, so this is like an approximate value for the full thing, but it depends on the this one. So once mu is different,
Mm.
sin I by
Ah.
sin R is mu, right?
Mm.
Okay, so
Mm.
I is same for both the colors, red and blue, because it's
Ah.
so one single white light. Within this
Mm.
white light, there is red and blue. So all the colors will have the same I. This is I, right?
Okay, sir. Mm.
Okay, and mu is different for different colors.
Mm.
So R has to be different for different colors. So
Mm.
that means when it's coming on this side, it will come in two directions. One will be
Mm.
actually red will get scattered less. So this should be a red light.
Okay, sir.
This blue light.
Mm.
That's how it gets split into different colors. The reason for that is this mu is depend on the color or wavelength.
Mm.
Difference between red and blue is wavelength is different. Corresponding frequency will be different. So the product is same. Because C equal to nu lambda, which is same for all colors. Okay. Since red is different from blue, correspondingly
Mm.
the wavelength should be different for blue and red. So the product is always same. Refraction.
Mm.
So white light will have all colors with JR. Violet to red.
Mm.
Okay, so but mu is different, so R will be different for different colors. R for red and R for violet will be different. So that's will get split
Mm. Mm.
because they'll go in different directions.
Mm.
The scattering I'll do later. So this thing is not there.
Mm.
Okay, next one is lenses. So what is a lens?
Mm. Lens is A mirror like something, no, sir?
Yeah. So you have a sphere like this,
Mm,
like a ball. Okay. You can cut it like
mm.
this, right?
Ah, yes,
Yeah.
sir.
And this thing will look like this. So this thing will have something like this one. Plain
Mm,
surface and a curved one.
mm,
Okay. It's like a
mm.
bowl. You take a bowl, whatever small bowl
Ha,
you have, and then just take the bottom slice of it. So it look like this. Okay. But the bowl is
ha.
filled with the material. But instead of doing this thing, I can do like this. I have one sphere and second sphere, two spheres, need not be same radius. And I'll take this one.
Mm,
So in
mm,
this case, both these surfaces are curved.
mm,
Here in this case, one surface is flat, other one is curved. Okay.
mm.
This is convex lens.
Ah,
Okay. Biconvex means both the things are of same radius. See, this convexes can also be like this one small sphere
mm.
and the bigger sphere. Okay. So this region, so one which has got small sphere, the curvature is more, bending is more. The one it is bigger sphere, the bending is less. Like you have a road like this, right? This is like a smooth bend, but the road can also go like this. It's a sharp bend, right? Understood?
Yes, sir.
Ah, so smaller sphere, the bending is more.
Mm,
Okay, bigger sphere is
mm.
almost flat. If you make this sphere bigger and bigger, then it's almost flat, like Earth's
Ah,
surface. Actually, it's just a globe,
mm.
right? It's a sphere, but you can't figure out
Ah,
it's a sphere because it's so big.
mm.
Okay, so when you cover large distance, you know it's a curve, or you should look from a outside
Ha.
space. Then you know
Okay, sir.
it's not a flat. So similarly for small sphere, the curvature is
Mm.
bending is more. For bigger sphere,
Okay.
curvature is less. The bending is less. Okay, so these two lens I can have two spheres of same radius. See the curvature is same, right? This one and this one.
Yes, sir.
At least assume it is same. So that's why it's called biconvex. Both the if I
Mm.
go this curvature as R1, this is R2,
Yes, sir.
radius of curvature,
Mm.
both R1 equal to R2. But here it could be different. R1 and
Ah,
like one small sphere and one bigger sphere. Okay.
mm.
Plano convection is one sphere and then you cut it with the plane surface.
Mm.
This one is two spheres, but so it's intersecting like this. One sphere is like
Mm.
this. Second sphere, the bigger sphere is like this.
Mm.
So this portion is this lens. Okay. So this is a one sphere, R1. This other sphere is R2. But here the center of both the spheres is here. Here the center of this sphere is on the left side. The center of this sphere is on the right side, like this one. Right? Here the center of both the spheres are in the left.
Mm.
Understood?
Yes, sir.
Uh, Similarly, here concave lens, it's opposite to this convex lens. What you have to do is assume there is a
Mm.
big chunk of
Mm.
glass like this. In this, you're creating a hollow thing of you're removing this glass
Mm.
of spherical shape.
Ah, ah.
Okay, and another spherical shape you're removing here, and this in between
Mm.
region, I'm taking this glass.
Mm.
That is this one.
Okay.
R1, R2. Okay, this is both R1 equal to R2, both same RR.
Ah.
Right, okay, yes. Plano convex is
Mm.
you take this one, I have a plain sheet like this, and
Mm.
this portion is this one.
Mm.
Okay, so I can also get like this.
Mm.
Okay, and the second sphere bigger like this,
Mm.
and then remove this glass here.
Mm.
Okay, basically
Okay,
these
sir.
two are spherical surfaces R1, R2, R1, R.
Mm.
Here both are same. It's biconvex.
Similar only.
Yeah. two spherical surfaces.
mm,
So convex lens, one more thing you can notice in the middle part, it is thick. Outside it is,
uh,
okay. Here
thinner.
it's thin in the middle, but thick on the
Mm,
outside.
okay.
That is concave lens. That's another way to figure out.
Okay. Okay.
The convex or biconvex, two spherical surfaces
Mm,
bounded by two spherical surfaces.
mm,
Plane means one side is plane,
mm,
one of the faces, it's plane.
mm,
Okay, other one is sphere. Here's what said there. Plane of concave is the same thing. One thing is plane, other one is a
mm.
spherical surface.
Okay, sir.
Okay, so
Uh,
the difference between these two is when I send a parallel beam of light
uh,
with a convex lens, it will focus. Okay,
mm,
for a concave lens, if I do the same thing,
mm,
if you send a parallel beam, they have shown in three, it's going away,
mm,
not converge at one point.
mm,
See, these are two parallel lines.
mm.
Okay. What are these two? Converging lines.
Converging lines.
Converging means it
Okay.
will meet somewhere.
Okay.
This will never meet. That's the
Mm,
effect of parallel, right? Another possibility is this
mm,
one.
mm,
It will never meet in the forward direction. So this is
mm,
divergent.
mm.
The distance between these two keeps on increasing. Here the distance is constant, parallel. Here the distance is
Uh,
increasing and finally it will meet.
mm,
So concave lens, if you send a parallel
mm,
beam, you'll get diverging rays. It's getting,
mm,
it's never going to meet. But convex
uh,
lens is the opposite. It will converge
mm,
this point.
uh,
Okay. So that point is called focal point.
uh,
So one thing is when the light ray, see, by symmetry can obviously
mm,
choose the center of the lens, right? Somewhere here, somewhere here. So for this one is the center. So that's called optical center or the center
mm,
of the lens. What they are used here.
mm,
And
mm,
ray of it strikes the obliquely, but optical center. Okay, that is this point,
mm,
middle of the lens. So this thing will not undergo any
mm,
traction, go just straight through. It's as if the lens is not there.
mm.
This is rule number one. This is true for both concave and convex. Rule
Uh,
number two is parallel to the principal
mm,
axis. After refraction,
mm.
it will pass through. Principal axis is the line,
Uh,
and there is some sort of symmetry of this line, right? About this line.
mm,
Principal, first thing it has to pass the optical center, and also is a
mm,
symmetry line.
mm.
You know what's a symmetry line? About this line, everything will look same.
Yes, sir.
Okay. For a
Mm,
circular disc, this vertical thing is the
mm,
symmetry line or axis of the disc. Similarly, this one is like a
mm,
disc only, which is thicker in the middle and
mm.
the thinner at the edges. So we'll have a
Uh,
symmetry, axis of symmetry. Okay. So that
mm,
is called principal axis. Okay. So
mm,
this is the principal axis. So if you take a ray parallel to the principal axis, after refraction,
mm.
it will pass through the
Uh,
principal focus. It will pass through a point in the principal axis. That point is called the focal point.
uh. Okay, sir.
Actually, before this, you should define what is focus. Focus in the sense like you said, parallel beam
Mm,
called beam because it's multiple rays, right? One
mm,
single thing is called ray. If you have a collection of them, it's called beam.
mm,
Okay, so here, after bending, all the right rays will meeting at this point. So this is the focus point.
mm.
Focus means single point attention, right? So this is
Yes, sir.
the point where it's getting focused. So first you
Mm,
have to define the focus, and then you have to say this one.
mm,
This ray will pass through the focus. Similarly, for this
mm,
concave thing, this light
mm,
ray will go like this, but if you project it
mm.
backward, the dotted line, you will cut the point in this axis. That point is called
Okay, sir.
focus. but it's virtual focus.
Ah,
Okay, so this is rule
mm.
number two. Ray parallel to the principal axis after refraction will pass to the focus.
Okay, sir.
First, focus on convection. We'll come to this later. Second one is
Mm.
reversing. See, light can always be reversed. Suppose instead of saying sending light this way, I can send this way.
Mm.
So we send this way, it has to come out this way only. Okay.
Okay, sir.
So the same thing I can draw in this direction here. I can
Mm.
put this whole thing this way and get this one.
Ah,
Okay. So the
okay.
light passing through the focus after refraction will become
Mm.
parallel to the principal axis. It's reverse
Mm.
to the first one.
Okay, sir.
Okay. Concave also, if
Mm.
you send a light so that this goes and meets at the focus after refraction,
Ah,
it's not parallel to the principal axis. It's the reverse of this one.
uh, okay.
That is rule number three.
Mm.
Goes to our enough. So, so there is a lens here. So object can be very, very far away. Now,
Okay, sir.
light rays from the far away object are approximately parallel.
Mm.
You know the reason?
No, sir.
Insert. See, there is some, let me take a simple thing, point source. The light will go like this, right? In all directions
Yes, sir.
by symmetry. Okay. But if you are nearby here,
Mm.
okay, you will see two rays coming like this.
Ah,
But if you go far and far away, those two rays which are reaching you will be approximately parallel.
okay.
Like, like two lines are here. Okay. If you watch these lines here, you might see there is an
Mm.
angle. If you go farther and farther away, this angle will decrease. I
Oh,
mean, the difference in angle will decrease.
okay.
But so when you go here, instead of watching these two, you watch these two. The infinite is coming out, right?
Yes, sir.
Okay. So these two will look approximately parallel.
Okay.
So far away, like sun, you know,
Mm.
when the light of that thing comes here, whatever light enters your eye, they will be approximately parallel.
Mm.
Even if it's not parallel close to the source. Because whatever
Mm.
is entering here will be coming out from a very small region. Because other things will
Mm.
go here. Okay.
Mm.
Your eye is here. So that thing which is
Mm.
entering there will come from a very small angle, which is
Mm.
approximately parallel. Okay.
Mm.
So that's why the light rays coming out from a faraway object is infinite will be parallel. Okay. So this
Okay, sir.
parallel beam will
Mm.
focus in the focal point.
B. Okay.
F. F2 is called the
Ah.
right side. This one we can call it F1. Because if I send the
Ah.
light in this direction,
Mm.
then it will get focused here.
Okay.
So to rejoin. Okay. So next
Oh.
from infinity, I'll bring the thing closer to the lens.
Hmm.